Hey everyone, welcome back. Today we're going to look at approximating square roots. So using a calculator, root 5 is 2.23606797775, and it keeps going on forever. Square root of 5 is an irrational number. So the decimal has non-repeating and continue forever like that. And so the value of square root 5 to one decimal place is 2.2. And the value of square root 5 to two decimal places is 2.24. And today we're going to look at finding the approximations of square roots to 1 and 2 decimal places. So I'll do lots of examples and then I'll have you guys practice right after. So let's take out the first one, root 5. So our setup is root 5 is in between root 4 and root 9. These are our perfect square roots, perfect squares, right? Root 4 is 2, root 9 is 3. And now we look at the distance between 5 and 4, 1. The distance between 9 and 4, 5. And so we look at this ratio, 1 over 5 equals 0.2. And you can almost think of it as root 5 being what percentage away from root 4. And that percentage here is 0.2. Between 0 and 1, it's 0.2. So in other words, root 5 is going to be approximately 2, right, square root 4, plus 0.2, like that, which gives us 2.2. So to one decimal place, root 5 is approximately 2.2. And just checking it really quick, 2.2 squared is 4.84. And so we know root 5 is a little bit bigger than 2.2. And we're going to use this when we go to two decimal places, but I just wanted to show you guys just how close it was if it's one decimal place. Okay, B, root 35. So it's the same setup. What are the perfect squares in between each? So we have root 25 and root 36. The distance between 35 and 25 is 10. Between 36 and 25 is 11. And so we go 10 over 11 as such, which gives us 0.9 approximately to one decimal place. And so that means this root 35 here is approximately 5, right? The lowest here, 5, plus 0.9, like that, which gives us 5.9. So root 35 is approximately 5.9. Okay, C, root 44. This is in between root 36 and root 49. So the distance between 44 and 36 is 8. Between 49 and 36 is 13. We look at that ratio, 8 over 13, which is approximately 0.6. So root 44 is approximately 6 from root 36 plus 0.6 like that, which gives 6.6. So the root 44 is approximately 6.6 to one decimal. And if we check here, 6.6 squared is 43.46. So we know root 44 is going to be slightly above 6.6. And we'll worry about that later when we get to two decimal places. But for one decimal place, root 44 is approximately 6.6. Okay, so practice 1. Find the value of square roots to one decimal place. Root 11, root 41, root 90, and root 55. Go ahead and pause the video and answer that question. Okay, root 11. What do we got here? Root 11 is between root 9 and root 16. The distance between 11 and 9 is 2. 16 and 9 is 7. So we look at that ratio, 2 over 7 is approximately 0.3. So root 11 is 3 plus 0.3 like that, 3.3. So root 11 is approximately 3.3. B, root 41. So this is going to be between root 36 and root 49. The distance between 41 and 36 is 5. Between 49 and 36 is 13. So we look at that ratio, 5 over 13 is 0.4. So root 41 is 0.4% closer to 49, like that. So root 41 is 6 plus 0.4, which is 6.4. So that's the approximation of root 41. Okay, C, root 90. This is between root 81 and root 100. Distance between 90 and 81 is 9. Distance between 100 and 81 is 19. So we look at that ratio, 9 over 19, and that's approximately 0.5. So root 90 is 9 plus 0.5. So it's approximately 9.5, like that. D, root 55. So this is between root 49 and root 64. The distance between 55 and 49 is 6. Between 64 and 49 is 15. We look at that ratio, 6 over 15, approximately 0.4. So root 55 is approximately 7 plus 0.4, which gives 7.4. So root 55 is approximately 7.4. Okay, let's kick it up a notch. Example 2. Find the value of the square roots to 2 decimal places. So we start off with the same thing for 1 decimal place. So root 20 is our example. Root 20 is between root 16 and root 25. So same thing as before. Distance here is 4. This distance is 9. So we look at 4 over 9, which gives 0.4. So root 20 is approximately 4 plus 0.4, which gives 4.4. And now we're going to look at the square of 4.4. This gives 19.36. So we're going to look at a little bit bigger. 4.5 squared gives 20.25. So we know root 20 is between 4.4 and 4.5. Meaning also root 20 is between root 19.36 and root 20.25. And this now is going to be our new distance to look at. So between 20 and 19.36, the distance is 0.64. And the distance between 20.25 and 19.36 is 0.89. And this is our new ratio we're going to look at. So it's a little more specific. So 0.64 and 0.89, that ratio is approximately 0.719. So we're interested in 0.7. Now we're not going to take 0.7 because we already did the decimal to the tenths. This decimal is for the hundredths. So we're going to add a 0 here. So take 0.07 like that. So instead of the tenths, we're going to take the hundredths. And so we're going to look at root 20 to be 4.4 plus this new 0.07 like that, which gives 4.47. So root 20 is approximately 4.47. So I'll do a couple more examples to really make sure you understand how this works. Okay, B, root 8. Root 8 between root 4 and root 9. First distance is 4. Second distance is 5. 4 over 5 ratio is approximately 0.8. So root 8 is approximately 2 plus 0.8, 2.8, like that. Now we take this 2.8 and we square it. And we notice that this is slightly less than 8. So we're interested in 2.9 squared, which is slightly more than 8. And so these are the numbers we're looking at now more specifically. So root 8 is between 2.8 and 2.9, like that, which is root 7.84 and root 8.41, like that. And so these are the new distances we're interested in. The distance between 8 and 7.84 is 0.16. And the distance between 8.41 and 7.84 is 0.56. So we're looking at this ratio now, and we get 0.285. And so this is 0.3, roughly. And instead of taking 0.3, we're going to take 0.03, because we're interested in the hundredths now. We already did the tenths right here. So we're interested in the hundredths. So we take adding a 0 here, 0.03. So root 8 is approximately 2.8 plus 0.03. So root 8 is approximately 2.83 as such. Okay, C. Root 77. This is between root 64 and root 81. First distance 13, second distance 17. 13 over 17, approximately 0.8, like that. So root 77 is 8 plus 0.8, like that, approximately. So we're going to take our 8.8 and we're going to square it. It's above 77. So we're going to look before that, 8.7 squared, and it's 75.69. And so these are our new middle values here, 8.7 and 8.8, which is the same as saying root 6569 and root 7744. The first distance here, 1.31. Second distance, 1.75. We look at that ratio, and it's approximately 0.7. We already did the tenths, so this here is for the hundredths. So we take 0.07 like that. So root 77 is approximately 8.7 plus 0.07. So root 77 is approximately 8.77 as such. Okay, time for some practice. Practice number 2. Find the value of the square roots to 2 decimal places. Root 5, root 44, root 11, and root 50. And when you're done, every single one of them, check your answers with the calculator. Okay, let's start with root 5 here. So root 5 is between root 4 and root 9. First distance is 1. 9 and 4 distance is 5. 1 over 5 is 0.2. So we have 2 plus 0.2. 2.2 is our first approximation. We're going to square 2.2, 4.84. It's not enough, so we add 0.1. So 2.3 squared, 5.29. So we know root 5 is between 2.2 and 2.3, which is another way of saying root 4.84 and root 5.29. We look at our first distance here between 5 and 4.84. It's 0.16. And the distance between 5.29 and 4.84 gives 0.45. So we look at this ratio here, gives us approximately 0.4. And so we take 0.04, because we already did the tenths. We're interested in the hundredths now. So root 5 is approximately 2.2 plus 0.04, which is 2.24. So root 5 is approximately 2.24. B, root 44. This is between root 36 and root 49. The first distance is 8. The second distance is 13. We look at this ratio, and it's approximately 0.6. So root 44 is approximately 6 plus 0.6, which gives 6.6, like that. So we're taking our 6.6 and we're squaring it, giving 43.56. So it's less than 44, so we add 0.1. 6.7 squared is 44.89. These are the numbers we're interested in. So 6.6, 44 root, and 6.7. Root 43.56 and root 44.89, like that. So this is our new distance. 44 and 43.56 is 0.44. 44.89 and 43.56 is 1.33. This is our new ratio we're interested in, which gives 0.3. So we take 0.03. So root 44 is approximately 6.6 plus 0.03, which gives 6.63 as our approximation. Okay, C, root 11. Root 11 is between root 9 and root 16. First distance is 2. Second distance is 7. So we look at that ratio, which is approximately 0.3. So root 11 is approximately 3 plus 0.3, which gives 3.3, like that. We square that value, 10.89, which is less than 11. So we go a bit higher now, 3.4 squared, 11.56. So we know root 11 is between 3.3 and 3.4, which is the same as saying between root 10.89 and root 11.56. Our first distance is 0.11. Our second distance is 0.67. We look at this ratio, and it's approximately 0.2. We already have the decimals for the tenths, so now we're looking at the hundredths. So we take 0.02. So root 11 is approximately 3.3 plus 0.02, which gives 3.32 as our approximation. D, root 50. Root 50 is between root 49 and root 64. The distance between 50 and 49 is 1. Between 64 and 49 is 15. 1 over 15 is approximately 0.1. So root 50 is approximately 7 plus 0.1, which is 7.1 as such. We look at 7.1 squared, 50.41. So we want to go less than that because we're above 50. 7 squared is 49. So root 50 is between 7 and 7.1, which is also the same as saying it's between root 49 and root 50.41. The first distance here is 1. The second distance is 1.41. We look at that ratio and it's 0.7. So we take 0.07. So root 50 is approximately 7 plus 0.07, which gives 7.07. So root 50 is approximately 7.07. And that's it. I'll see you guys in the next lesson.